Hi, this is Mayor from Angel DAO, and today I'm going to give a tutorial how to build a cross-chain messaging application using deBridge. deBridge is a decentralized protocol for cross-chain interoperability, and one of the cool things that you can do with deBridge is you can basically call a function on a contract on another chain, pass in parameters, and this all works through a network of decentralized validators. So um, what we're going to build today is a Uniswap v3 TWAP Oracle. What that does is it takes the Uniswap v3 TWAP price from a chain such as Polygon or Arbitrum, even Ethereum mainnet. Then it can be sent in a decentralized way to another chain such as Binance, Avalanche, in the future many other chains that don't support Uniswap v3. And the potential use case there is many DeFi applications that are lacking trustworthy Oracle sources on-chain oracles, especially newer chains. Those chains will be able to have the data bridged from a larger chain that has that kind of data available on-chain. So taking a closer look at deBridge, let's go to the deBridge Explorer. And you can see basically we have 12 validators. So each of these validators is running the deBridge protocol, and it's a standalone protocol where you stake your deBridge tokens, and validators are incentivized to be good actors because they can be slashed. So there's a kind of a incentivization mechanism that's maintaining honesty among validators. So yeah, we'll come back to this later, but we can start with the code now. So you can see we have here our project, deBridge TWAP Oracle. It's a standard hard hat contract. So we have a couple of contracts here which we'll look at. We have scripts, so deployment script and some other scripts. We have some tests. We have a TWAP to price sort of little script here which will convert the TWAP tick into a TWAP price that's human readable. And then we have some of our normal hard hat parameters here. So starting with the contracts, we have bridgeapp-base.sol. So everyone building on deBridge is going to have this contract. It's essentially boilerplate. And yeah, you don't need to really change this contract at all. We will interact with this contract using the scripts. So we will call set contract address on chain ID from the sending chain. And then from the receiving chain, we will call add controlling address. So you can see we have two scripts here which do just that. Other than that, there's nothing to really change or interact with in this contract. Next, I'll go to the TWAP oracle.sol. So this is our main contract. You can see it inherits bridgeapp-base.sol. And so we have the initialize function, and this takes in the deBridge gate. So if we go to constants, you'll see we have this deBridge gate address. And essentially, when we send a cross-chain transaction on deBridge, before it gets to the validators, we send it to the deBridge gateway, and then the validators pick up the contract from the deBridge gateway. So currently, this address is the same on all chains where deBridge is deployed. This address is also available in the deBridge documentation. In the constants, we also have chain IDs. So from chain, in this case, is Polygon, and to chain ID is Binance Smart Chain. And after we deploy, we're going to put the addresses here of the contracts that we've deployed before we start executing some of these scripts. Okay, so let's go back to TWAP oracle.sol. So we have a couple events here. So our goal is basically on Polygon, we want to just emit that we've set the tick, and then on Binance Smart Chain, we want to emit receive tick with the pool on the tick. And this is basically sending the Uniswap v3 TWAP of a given pool cross-chain. So, okay, let's take a look at get v3 TWAP function. One of the parameters we have is the Uniswap v3 pool. We have the TWAP duration, the chain ID 2, which in this case will be Binance, so I think 56. We have address fallback. This is a deBridge specific parameter. And execution fee, which is also a deBridge specific parameter, which you can kind of tinker with in the deBridge documentation, tinker with the execution fee and the scripts. You'll also notice that this is a payable function, so we are going to send, in this case, some native Matic tokens in the transaction in order to cover the deBridge fees. Okay, so yeah, starting on line 28, we have the Uniswap v3 Oracle part of the code. So we have here the TWAP duration, and right here we have 0. So essentially what we're doing is we're observing from a slice of time from the most recent observation all the way back until whatever we put in for TWAP duration. So this lets you kind of decide what you want the duration of the TWAP to be when you call this function. And then, yeah, we have the standard Uniswap v3 pool observe, and then this is just math that converts it into a tick from a bunch of different ticks using the TWAP. So we're going to go from a bunch of different ticks in between this to an average tick, and then we're going to emit the sent tick event. So it's going to have the pool, which is again something we sent in here, the pool, the up duration, and the tick, and the block number. So the tick is not actually very useful for like humans. It just looks like a random number to us, but it can be converted with no additional information, just with plain math into a price, human readable price. So here we have the deBridge parameters. So we have some flags, which you probably don't need to worry about. We have execution fee, which we're passing in here. We have the fallback address, which we're also passing in here. And then this is where the magic happens. We have the data. So we're going to encode with selector this function onBridge message here. And this is just an easy way to encode the function with the parameters, pool and tick. And then here we have the contract address that we're sending to. So we're going to send that as well. And that is actually going to be something that we're going to set with the set contract address on chain ID method that we saw before. So we're going to set this after we deploy the contract. And then, yeah, so we're going to basically include our small fee here for using deBridge with the message value, the data, the contract address 2, chain ID 2, and this is going to be sent to the deBridge gateway where it will be picked up by a validator. And then essentially once it's confirmed by deBridge validators, it will be executed. Well, this function here, onBridge message that we encoded, will be executed on the receiving chain, in this case Binance Smart Chain. And on Binance, we will emit an event receive tick with the pool, the tick, and the block number on Binance. You could also pass in the block number from Polygon if it's specifically needed. And yeah, that's basically how the contract should work. It's also interesting to note that we're deploying the same contract here, TWAP Oracle.sol, on both Polygon and Binance. So even though in our case we're only going to use this part on Polygon and this part on Binance, you can create contracts that are kind of backwards compatible back and forth across both chains. So that's just kind of a neat feature of deBridge. We also have one other contract here, which is just for testing purposes. This is just really simple to get the tick. If you want to test out some ticks from, let's say, Polygon, just change the pool address. You can go to the Uniswap v3 Explorer, get some popular pools, get the ticks, and then you can mess around with the math to change the tick into a price. And I'll note also, if your use case requires receiving the tick on-chain and turning it on-chain into a human-readable price, that is possible as well using UniV3 math. You would, however, have to have a separate contract to do that because, well, there's a few ways you can kind of game it, but the Solidity versions are quite different between the Uniswap v3 math libraries, as you can see, and the deBridge gateway stuff. So, but it is possible to convert the TWAP tick into a TWAP price on chain. Okay, so we have here, as we mentioned, scripts, some basic tests. this is basically a script to turn the TWAP tick into a TWAP price. And then we have standard like hard hat config. So you can see we have the Solidity versions. This is the version for TWAP format.sol. This is the version for TWAP oracle.sol and bridge app base.sol. We have the two networks that we're using, Matic and Binance Smart Chain. You'll note also I've kind of just customized the gas because on Matic, if you don't kind of put a very high gas price, sometimes your transactions get delayed a long time. So you'll see also in the scripts I've done similar for Binance as well. And then, yeah, one other thing we have here is our Etherscan API keys. So we have two of them. I'm just going to switch back and forth when I'm verifying the contracts on Polygon or Binance. So that's really all we have for the hard hat config. So we can now go ahead and deploy the contract. So we have here a standard deployment script for hard hat. We're using OpenZeppelin upgradable proxy, so we'll be able to just upgrade the contract through a proxy contract. So we're going to get out of this a proxy and an implementation address. So we're going to go ahead. Well, first we can actually run our tests. So we do have a few tests here, some basic unit tests. And if you wanted to kind of improve testing, you're obviously not able to really test. And if anybody knows somebody that's working on something for this, I think it could be really cool. Please leave a comment in the video. But it's not really possible to test the cross-chain part of cross-chain protocols, right? You can test like whether you're plugging in the right data on one side of the chain and whether the method to receive that data on the other chain theoretically works, but you can't really test if the data is going cross-chain per se, if the cross-chain protocol itself works. So to make things a little bit easier for testing, it is also possible to kind of separate out some of the logic here that's not directly related to deBridge into another function and then just call that function and then write tests for that function that has, like in this case, Uniswap v3 math. But yeah, so we'll go ahead and just run a few tests here. So yeah, we're going to basically check the version, check if it's initialized, which is basically checking if the deBridge validator, if the deBridge gateway is correct. And then basically, yeah, we're going to check to the best extent of our abilities that there's no error here on either side. Again, we can't really test if the deBridge protocol works using unit tests currently. So that's something that probably over the next couple of years, there will be companies that work on solutions for like cross-chain testing, but currently it's not really available. Okay, so we're ready to deploy. We're going to basically just run a deployment script here, deploy.ts. So we're going to deploy again. We're going to deploy TWAP oracle.sol on both Polygon and Binance. So let's go ahead and do that. Start with Polygon. So I'm just calling it Matic in my hard hat config, but you can call it Polygon. And yeah. Okay, so now we're going to deploy on Polygon. We're using this deploy.ts script. Using the OpenZeppelin upgradable proxy. So we'll have a proxy address and an implementation address. And that just allows us to upgrade the contract over time. So you can see we've deployed, here's the proxy address. So we're going to go to constants and put that in for the address on from. And for the implementation address, if this is the first time that you're deploying, we're going to have to verify the contract. So you'll just take the implementation address, npx hard hat verify, and in this case it's not going to work because I've already verified the contract, same exact contract. But if it's the first time you're deploying, or if you've made breaking changes, then you'll have to do this again for a new implementation address. Okay, so next step, we're going to deploy on Binance Smart Chain. Same deploy script. And same thing with the opens up unupgradable proxy. We're going to take the proxy address and put in our constants file. And then we'll run the rest of these scripts here. Okay, so, and again, you would verify this contract in production. You would just switch out the Etherscan API key here for your Etherscan fork. So if we're verifying for Binance Smart Chain, we would switch it to BSC scan, and then we would run the same npx hardhat verify, but for Binance with the implementation address. Okay, so we're going to save the constants.ts file with these proxy addresses. And now we're ready to run these scripts. So the first script is going to be set contract address on chain ID. So this is interacting with the method we saw earlier in bridgeapp-based.sol, and this is basically just setting the contract address and the chain ID that we're going to be sending to in TWAP oracle.sol. So let's go ahead and do that from Polygon. Contract address on chain ID.ts. Okay, now we're going to do add controlling address. This is the same thing, but for the receiving address. So we're going to run this on BSC using our BSC address. You can see it's using the address on from and the from chain ID. So npx hardhat run add controlling address.ts. Okay, so now we've done the prerequisite deBridge setup, and we're ready to actually send the cross-chain transaction. So we have the send script here. So you can also execute this from Etherscan or really anywhere. Here we have the Uniswap v3 pool. So this is the wrapped Ethereum USDC pool. If we go to Polygon Scan, you can check it out for yourself. See that the tokens here are wrapped Ethereum and USDC. TWAP duration. We have the execution fee, which is 2 Matic. We have the value that we're sending, which is also for the deBridge fees, 3 Matic, so it's like maybe $1.50 at current prices. We have like some custom gas price and limit for Polygon. And then we're going to basically pass in the parameters here. And after that, we're going to wait for the transaction to complete, and we're going to check it out on the deBridge Explorer. So let's go ahead and run this on Polygon. Okay, so the transaction is pending, and we're waiting for the receipt. Okay, so we have the receipt, and using that, we're going to use this link here that has the transaction hash and the chain ID, and we're going to go ahead and open that link in our browser. So, okay, you can see that this transaction has been submitted to deBridge. deBridge is currently using 256 block confirmations for Polygon just because there's a ton of blocks on Polygon and potential for reorg, so that adds security to ensure that like the assets that are being transferred cross-chain are at the final destination. So now we're just going to wait and come back once this is verified. So you can see we have 16 block confirmations, so I'll come back in a minute when we have a full 256. Okay, so as you can see, we just had a confirmation on Polygon, 256 blocks, and now you'll see we have deBridge confirmations as well. the deBridge confirmations happen quite quickly, and we're almost at all 12 validators now, so the entire deBridge network has confirmed. And we're going to await the execution on Binance Smart Chain. Once that is executed, we'll have a link to the transaction, and we'll get the cross-chain TWAP tick. Great, so we had execution. Here's the execution transaction on Binance Smart Chain Scan. So just to read the events easier, I'm going to take that over to Tenderly, take the transaction hash, go to Tenderly. You could also just read it on Binance Smart Chain, but it's easier here. And there's a few deBridge related events that have been emitted, and then here we have the received tick event. So as you remember from TWAP.workhold.sol, received tick, we want this executed on Binance Smart Chain, and it was. So we got this tick here, we have the block number, and we have the pool. So I'm going to go ahead and take the tick. We already know the pool, and so I'm going to go to our TWAP to price script here. I'm going to paste in our current tick, and because we know the pool, we know the decimals of each of the tokens in the pool. So this is USDC and this is wrapped Ethereum. So just have to play with that on a per pool basis. We're using the UniV3 prices library, really handy for doing this off chain. And again, if you do need to do it on chain, you can use the UniV3 math libraries here, but I'm not gonna, that's beyond the scope of this tutorial. Okay, so now all we need to do is cd into that directory, TWAP to price, and then just node index. And here is the TWAP ETH price right here, 2015. If we go to CoinGecko, we'll see that is the current price of Ethereum roughly. Obviously, we're talking about on Uniswap V3 on Polygon, so if there's a few dollars difference, that's just to be assumed. And yeah, we basically completed the goal, which was to bring cross-chain TWAPs. You could obviously store the TWAP in the contract. It doesn't have to be just events that you're emitting. This is just kind of for demonstration purposes, but you could use the TWAP to do something. You could call another contract with the TWAP, which could, in that case, something like this, turn the TWAP into a human readable price using the Uniswap V3 math library. So there's a lot of things you could do with it. And yeah, so that's basically the complete tutorial how to build a cross-chain application with deBridge. If you have any questions, please reach out. And also, if you're building a cross-chain application and you want to use deBridge, please feel free to reach out, and we'll be happy to help you from AngelDAO to set up your project and just kind of give you some advice about, you know, getting it working and using deBridge. So yeah, thanks for watching.